hopefully the stream won't freeze up again. But I'm currently right now in Stony Brook, and you see how hazy the sky is? This is because of wildfire smoke coming in from California, Oregon, and Washington. I mean, this is why the sky's looking so white right now. This is not cloud cover, by the way. This is actually nothing but smoke. Smoke and dust. Well, smoke covering the atmosphere, the mid-level. The smoke is actually at jet stream level around 15 to 25,000 feet, which is why here at ground level, there's no humidity. It doesn't feel humid. Normally, when the sky is like this, the way it is right now, it's normally very hazy and humid outside. Yes, the sky is hazy, but the visibility at ground level is incredible. It's really good. There's no poor visibilities. Like, you could see Manhattan even from Long Island. Like, there's nothing obscuring the visibility because the smoke is very high up. And there's nothing that is causing the air to be stagnant. In fact, it was pretty breezy last night and yesterday. But all the smoke is traversing the whole country and is causing this hazy skies here. That's how bad the wildfires are in California. The wildfires are so bad that they are reaching the East Coast. Yes, the smoke from California is reaching us here on the East Coast, here in Long Island. I'm currently here in Stony Brook. And there is smoke up aloft reaching here in the New York City area, past even east of New York City. I wouldn't be surprised if some of this wildfire smoke will even reach Europe and also make the skies a little hazy. And because it's in the upper atmospheres, these wildfires are having the same effect as volcanic eruptions. Usually massive volcanic eruptions kind of cause the same effect. In fact, after the eruption of Somalis in 1257 AD, which was a VI7 eruption, there was report of dry fog in Europe. Dry fog. What is dry fog? Basically fog that doesn't limit visibilities but make the sky hazy. This could be considered a dry fog because the sky looks hazy and foggy, but while it doesn't limit visibilities because it's not smoke. When people say dry fog, especially in ancient times, during the times of the Middle Ages, there were something called dry fog usually happens following a volcanic eruption. Usually, this is how the sky is because of sulfuric acid and ash in the sky. But this is not sulfuric acid or volcanic ash. This is smoke. This is nothing but smoke from wildfires, from burning carbon. And it's making the sky hazy. It's limiting the amount of sun that's reaching the ground. And likely it is reflecting sunlight into space, therefore slightly increasing the albedo of the Earth, especially in the sky. But you don't have sulfuric acid from this. The only thing that produces sulfuric acid, natural events, are volcanic eruptions and volcanic vents. Even when volcanoes are not erupting, they do emit small quantities of sulfuric acid, sulfuric dioxide, which goes into the atmosphere, but it doesn't do much. The only times it would change the climate is if the sulfuric acid reaches the stratosphere, which here at about 40 to 45 degrees north latitude is roughly 50 or 60,000 feet, or about 50,000 feet. The higher north you go, the lower the troposphere is. In fact, around the Arctic, it's around 40,000 feet, 40,000 feet. And in the tropics, it's about 60,000 feet, or a little even above that. The atmosphere over the Arctic is actually thinner than, the amount of atmosphere there's less atmosphere because of temperatures than at the tropics, where the atmosphere is denser. That's why you have a higher troposphere over the tropics than you do over the Arctic. But speaking this aside, we are having a lot of wildfire smoke here in the New York area. And last year at this time, the sunsets were purple because of the Rycock eruption in the Kuril Islands. While the eruption itself was not very big and was even smaller than the eruption of Mount St. Helens, it still produced a colorful effect all around the Northern Hemisphere. Even in Florida, it was observed. I mean, one could argue that it was maybe a 5, maybe a low NVI 5, because this eruption did change how the weather would normally be. It did affect the weather because there was enough sulfuric acid to cool down the Arctic enough that the polar vortex did not go negative. The Arctic oscillation stayed positive for most of the winter, which is why we did not get much snow last year. This year, on the other hand, I'm getting mixed signals. We're in a La Nina, which would normally support a blocking pattern. Here's what La Nina does. La Nina makes the Northwest dry, makes the West Coast dry, and the East Coast, especially the Northeast, stormy. So what a La Nina typically does is it makes the flow, instead of zonal, more wavy. So you'd have ridges in the West Coast, troughs on the East. So, and this ridging on the West Coast would support a blocking pattern over the northeastern United States, especially in Greenland. And this blocking pattern would support snowstorms and nor'easters going up the coast. And you get a negative North Atlantic oscillation. Even in El Niños, you could get a negative NAO. But how do you get a blocking pattern off of Greenland or off of Labrador, is you get warm waters building in the Labrador Straits. Basically, between Newfoundland and Greenland, you have a lot of warm water there, which would support a high pressure system further south and west towards Labrador. And having a high pressure system over Labrador would basically allow storms that would usually quickly go out to sea to basically go up the coast and produce lots and lots of snowfall. So this year is again giving me mixed signals. Why mixed? Because in the Northeast Pacific, we usually get a positive PNA, or the Pacific, the PDO, this year right now is mixed. That's one signal. So if you're getting, because back in 2010, 2011, the PDO was showing a cold signal, which would normally support, stormy weather for the Northwest United States, which happened. So you get storms, coming around Alberta, and then go through like the south. They'll come in from the West Coast, go into like the Great Plains, Southern Great Plains, and then go up the coast. And some of them would just crisscross the country, but they wouldn't be super fast. You kind of had a similar, but instead of going crisscross, they were more like coming up the coast, like they would come in from the Gulf and go up the coast, even though we were having a La Nina. It wasn't because of the subtropical jet stream this was happening, but because of so you have a trough, so you would have instead of having a wavy trough, wavy pattern, you had more of a pattern of like a big trough in the United States, just one big trough. And this trough basically supported these cross-country snowstorms, which would start off in the Northwest, dip south, go into the Gulf or near the Gulf, and then come up the coast. This could happen this year as well. I'm seeing that possibility, that you're going to have a very stormy East Coast, basically. You're going to have a lot of storms going up the coast this year. I don't know if it's going to be like 2010, 2011, or 2014, 2015, but you will likely have a few storms going up the coast. All right, thank you all for watching, and have